In this video, we are going to describe the sorting by reversals. Now, we are going to pass to the second part, called sorting by reversals. And this is an example of a DNA strand in which we have synteny blocks. We remember what the synteny block is. It's a block of DNA that doesn't go through random mutation, like a haplotype, for example, is a synteny block. In this case, the block is ordered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's happening something that we call a reversal, okay? It happened in this loop, and at the beginning, the sequence, the permutation was 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here we are going to cut it. Nature has a random breaking event. As a consequence, now the permutation is 1, 2, 3, minus 8, minus 7, minus 6, minus 5, minus 4, plus 9, and plus 10. Now we got two breakpoints. What is a breakpoint? Is a disruption in the natural order. Now we are going to introduce some formal definition. What is a permutation? A permutation of a set is an arrangement of its members into a sequence, but not an ordered sequence. We can have a permutation can be even a not ordered sequence. For example, for the set 1, 2, 3, 4, 5, 6, 7, I could have a permutation 1 that is composed by the numbers 2, 4, 6, 1, 3, 5, and 7, or a permutation 2 composed by 1, 3, 5, 7, 2, 4, 6. Any arrangement of the member of a set is a permutation. Now we are going to define what is a reversal. Given the original sequence N1, N2, Ni, Nj, and N, a reversal is N1, N2, minus Nj to minus Ni to Nn. And we are going to return to the previous example. This is a reversal 4 to 8. As a consequence, the reversal of a sequence 4 to 8 is 8 minus 8 to minus 4. I'm going to initially vote 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now became 1, 2, 3, minus 8, minus 7, minus 6, minus 5, minus 4, plus 9, and plus 10. And the reversal introduce 2 breakpoints. Which formal definitions do we have? In mathematics, a permutation is a set is an arrangement of its members into a sequence, as we saw before. And apology, we just go through this slide before. So the reversal of the string 1, 2, 3, 4, 5, 6, 7, 8 from 4 to 7 is 1, 2, 3, minus 7, minus 6, minus 5, minus 4, 8. And now we are going to show you a rearrangement scenario with 5 reversals. We have a step 0, 2, minus 4, minus 3, 5, minus 8, minus 7, minus 6, 1. One moment, please. I have to interrupt the class again. Okay. So it's 2, minus 4, minus 3, 5, minus 8, minus 7, minus 6, 1. This is the first rearrangement scenario. This is the max, my apologies. After, I'm going forward, and I'm going to do an arrangement of this minus 2 and minus 3. They look like very similar. I arrive to 2, 3, 4, 5, minus 8, minus 7, minus 6. And I notice that 5 is very similar to minus 6. So it's 5, 6, 7, 8. And 1. Now these look like nearly ordered. I apply a reversal to 1 and became minus 1. And at the end, I can see that I have 2, 3, 4, 5, 6, 7, 8. So I apply a reversal to this one and becomes minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. That it is a very nice permutation because it is reverse order. And now it became 1, 2, 3, 4, 5, 6, 7, 8. So, and now I show an arrangement with 4 reversals. It is the same sequence, but I'm going to apply only 4 reversals, okay? 2, minus 4, minus 3, 5, minus 8, minus 7, minus 6, 1. I'm going to reverse these 2. Minus 4 and minus 3 became 3, 4. And so I have 2, 3, 4, 5. And I have to reverse it now. 2, 3, 4, 5, I'm going to reverse it. So I'm going to be minus 5, minus 4, minus 3, minus 2, minus 8, minus 7, minus 6, and 1. And now I'm going to reverse this part. It became minus 1, 6, 7, 8. Why? Minus 1, 6, 7, and 8. And I'm going to reverse this one, 6, 7, 8, minus 1, minus 2, minus 3, minus 4, and minus 5. And now we have 1, 2, 3, 4, 5, 6, 7, and 8. Now we have the reversal distance problem. How to calculate the reversal distance between two permutations? So as input, we have two permutations, and as output, we have the reversal distance between them. Okay. And this is called sorting by reversal problem. To calculate the reversal distance between a permutation and the identity permutation 1, 2, n, the input is a permutation P, and the output is the reversal distance between P and the identity permutation. So now we are going to apply a greedy sorting by reversals. Greedy means I'm going to select at each option the best one in a one-step solution. Here I have plus 1. And I want to have the number 2 at the second one, so I reverse this sequence from 2 to 7. As a consequence, I'm going to have minus 2, plus 8, minus 9, plus 10, minus 6. Here. Plus 7, minus 11, minus 3, plus 5, plus 4. Now, what I have here, identify the number 3, and I do a reversal between this point, plus 8, and this point, minus 3. So it became 1, 2, 3, 11, minus 7, plus 6, minus 10, plus 9, minus 8, plus 5, plus 4. This is plus 4. As a consequence, I want to put it here, beside 3. And I have 1, 2, 3, minus 4, minus 5, plus 8, minus 9, plus 10, minus 6, plus 7, minus 11. Minus 5 is just order, so what I'm looking for is 6. Minus 6 is here. And going in this way, I'm going to obtain the initial sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.